Awesome. Well, good morning, everyone. Thanks for your patience. Really excited to be here today. And welcome to Cloud Console Cartographer. Tapping into mapping is greater than slogging through logging. So first, a brief introduction. Who are we, and what are we going to be talking about?
Good morning, everyone. Has everybody got caffeine? Sweet. My name is Andre Amete. I live and work in Pristina, Kosovo. Recently graduated for computer engineering. Background, I started working at Permiso Security almost a year ago as an associate threat researcher. Recently, I published an open source tool called CloudTrail, so you have the link below if you want to give it some love.
And my name is Daniel Bohannon. I'm from the USA. I'm a principal threat researcher with Permiso. I've been in the security industry for about 14 years now. The last couple roles I've been in were incident response and researcher at Mandiant, and then also spent a couple years at Microsoft. I've been at Permiso for about a year and a half now. And I'm a big fan of security research. I love these conferences. I love open source tools and have a deep fascination with obfuscation and looking at common things in uncommon ways. I'm always taking an offensive approach to a defensive mindset. So with that being said, logs. We're here to talk for 40 minutes about logs and keep you interested and exciting. So what's the role of logs? Well, as a defender, logs are visibility. They tell me what has happened in an environment. Often, people do not enable logs, and typically attackers do not do this for you. So know what logs you're capable of recording and turn them on. Secondly, move them to another location so that you have duplication, replication, so it's harder for an attacker to go and remove those logs. And then do something with them. You don't just want to have logs to look at when there's been an incident. You want to monitor them and see proactively, is there something that is suspicious that you should be looking for? I'm going to briefly talk about some of the differences, in my opinion, between kind of on-prem and cloud logs. Now, this is not the storage location, it's more of the data source. So what are some differences between host-based logs, network logs, and then cloud logs? From a host and network perspective, they've been around a lot longer. You have more options for forwarders, for tools to look at the logs. In my opinion, they're a lot more granular. Think of how much information you can get from something like Sysmon. You can get process information, image loads, network connections, even the contents of files that attackers might be using for binaries or scripts. So there are a lot of opportunities for fingerprints to be left unknowingly by an attacker. And in the world of incident response and forensics, it's just a beautiful thing to find all these secondary effects that come from an initial action from an attacker. But things get a little blurrier with cloud. There's not quite as much control. You are basically beholden to whatever the cloud provider gives you. And typically, most cloud providers break up their logs into control plane and data plane log. Control plane is typically enabled by default, and it gives you information about the management and configuration of everything within that environment. Data plane is typically not enabled by default. So control plane can be like the configuration of an S3 bucket. Data plane is every time someone requests something from that bucket or uploads something to it. And it's typically not enabled by default just due to volume and cost. There are also different retention limits, which we'll talk about in the next slide. But typically, they're a little less granular because cloud logs are basically a record of an API call. It's not even something that is logging activity on an endpoint or device. It's already abstracted one layer. So finding those fingerprints becomes more about grouping less precise information into a larger aggregate data. So let's talk a little more about cloud logs for defenders. So if we were to look at, let's say, AWS and Azure, this is an example of doing something really simple. We're just creating a new user, in this case called Quileva. We can see here there's kind of similarly named events and the name of the user that was created between these two logs. So what about actually querying these logs? How do you actually get to what we just saw? Well, you have the opportunity to hit the API that the cloud providers give you. One of the pros is it's the least delayed. You don't have to worry about getting a secondary replication. You can get it right from the source, sometimes even a few minutes earlier than some other locations. One of the cons, though, is retention. AWS CloudTrail, you can go back 90 days. Azure's only 30. Does that matter to you? It's at least something you should think about and know what the limitations are. Forwarded, though, gives you the ability to have however much storage you want. You can retain it for 5 years, 10 years if you want to. And typically, storage is not too expensive. Again, it all depends on the volume that you're talking about. There's also no API throttling. So for example, CloudTrail lookup events, you can hit 2 times per second. Now that's still a lot, but when you have a lot of different security tools competing for that, you can hit API throttling pretty quickly. It's also a bit easier to consume by other tools. If it's already replicated onto an Azure storage blob or an S3 bucket, anyone can consume that data and you can control access to that storage location rather than giving someone access to be able to hit an API in your account. One of the cons, though, is that sometimes you're actually missing metadata. If you query logs from CloudTrail, then you'll actually get an entire different section of resources with a resource type and resource name. If you forward those logs, that data is completely missing. So it's important to kind of diff the two options and see if that matters to you. Also, additional monitoring. Anytime you introduce another step into the pipeline, you want to make sure that you're monitoring the health of that step to make sure that those logs are flowing correctly. So when we use the word console, this talk is called Cloud Console Cartographer. This is a bit confusing because typically console means like a terminal, a black terminal window, or blue if you're a PowerShell user. But in this case, console, hey, can we actually go back a slide? Console is referring to the AWS management console. So it's the actual web browser that you log into to look at your configurations to manage your environment. Hey, can we maybe get some other batteries in this? Thank you. Do people actually still use console? The answer is yes. Legitimate users and attackers still use console today. There's 2 different threat groups that we've seen do this quite a bit, Lucre3 and Lucre1. Lucre3 is also known as Scattered Spider or Roasted Octopus. They actually use console pretty prolifically. Sometimes maybe that's just because they might have PDFs, that's their runbooks, and it says click here, do this, do that. Some attackers are still learning cloud, but it's lucrative enough for them to still break in because many organizations are not too advanced in their cloud security configurations. Sometimes there are also technical reasons why someone might use the console. Can we go to the next slide, please? For example, we've actually seen a case where an attacker they basically broke out of an ECS container and they had a federation token. And what's interesting is that if you look at AWS documentation, if you have access in a federated token, there are some limitations. Like you cannot access the IAM service via the CLI or an SDK. But that limitation does not apply to console. And that's precisely what this attacker did. As soon as they broke out of that ECS container, they then went straight to the management console and then went right to the IAM service to create a user, login profile, all the rest. So there are technical reasons why attackers still might use the console.
So cool. Deepo showed us 2 examples of cloud logs, both in Azure and AWS, but how do they look from the log volume perspective? And for that, we're going to do some enumeration process in AWS console, listing some user policies, roles, EC2 instances, and we'd be surprised on how many events are generated by those simple read-only clicks. Azure, on the other hand, tends to do things differently. They only log change or update events. So if we were to do the same enumeration process in Azure portal, like listing user, blobs, or containers, we'd be muted and get no logs at all. And speaking from a security standpoint, you always want to know if an attacker is doing the enumeration process of your sensitive data in your environment. And for that, Azure kind of gets a free pass from our problem, not because they are doing a better job, obviously, but since they don't provide us enough logs to actually make sense of what's happening in their environment. And with that being said, we're going to focus only on the AWS part where we can actually get that information. Let's jump down to the main part of the presentation, which is the problem of noisy console logs. We all love logs here. They shine our path towards the truth, but sometimes too much brightness can make you blind and leave you out in the dark. But the main problem here is not the absence of logs, just like we discussed that Azure doesn't log many of these things. It's actually the sheer volume of logs that get generated from the console session in AWS. And sometimes it feels just like playing the Atari Super Breakout game, where we can think that every single UI click that we do is just like when the ball goes from a paddle, hits one brick, so you have that one-to-one correlation, so one request, one response, or even say better, for each single UI click, you get only one event generated. But that's obviously not the case at all times. Sometimes the ball goes from a paddle, goes way over to the top, hit tens, if not hundreds of API calls in the backend, and we're going to see later on slides that's actually the use case in some of our console session. Back to you.
Thank you. So, how did we come across this? Well, we look at a lot of logs and we realized, wow, there's a lot here. How do we even make sense of what happened in this 1,000 event console session? And we see a lot of these events are occurring in the exact same timestamp. So what we decided to do was we created an identity called no permissions, and we gave it no permissions. We only gave it a login profile and then started to go through the console. And what we found was many different errors started showing up. And you can see all these different widgets in the console have these different errors. So let's click to the IAM dashboard. We see even more errors. Let's just start to kind of pull those over to the side. And basically try to understand, are these consistent across every time you visit these different pages? So if we click on users, we have list users. Let's actually use this one as an example. If we focus just on list users, then what if we gave ourselves just that access? So what if we can make it one step further? Like if we give ourselves an inline policy, now we can actually make a little more progress. Now it lists the users, but you'll notice that each column are more errors with different API calls. How do we actually approach this and say, understanding list users, what are these other events? How are they required? How do we figure this out?
Cool. In order for us to be looking at the data that Debo just told, we need to crack open the hood and see what treasure is inside of it. And from there, we extract four golden rules that we live by. First, full permissions. Our user needs to have full permissions in order for us not to be losing time and giving ourselves manual permissions for every action we're trying to do. New environment or a clean environment per each service. Lots of Excel spreadsheets where we track our time of our actions. And my favorite one, lots of coffee or any coffee and drink of your choice. Let's go back to the IAM user part, where we have three scenarios. The first one, where our user has no permissions at all, besides breathing and just logging into the profile. Scenario B, where our user has only one action allowed, and that's the IAM list users. And the last scenario, scenario C, where our user has full permissions in the environment. Now let's see what events are generated in the back for each scenario. For scenario A, we have only one event generated, and that's the IAM list user, which was obviously denied due to lack of permissions, so nothing fancy going on here. If we move down to scenario B, we obviously see more events generated. And the difference between these two scenarios is that in the scenario B, the IAM list user event was successful indeed, and we see five other grouping of events which occurred but were denied due to lack of permissions again. Moving down to scenario C is where things start to get interesting. We obviously see that the first event is again successful. We have the five grouping of events, which in this case were successful as they occurred once per identity. So we know that occurred also in the previous scenario and in this scenario. So we're going to move them to our map on the site. And now we shift our focus down to the two additional events at the bottom. So we have the event get access key last used. And they occur only if the user has an access key present. So a user may contain 0 up to 2 access keys, but they may have none. So this event might never occur. Our approach to this problem is, let's list these events in 3 groupings. The anchor event, which is the main event that must happen at all times, the required events, and last, the optional events, which are, again, are events that may happen, but if not, they won't be a deal breaker to us.
So let's talk a little more about optional events. We kind of break this up into 2 separate categories. One is kind of the background health events. If you're still logged in, there's going to be some events that show up. So even just logging into the console home session, we actually can define these into the events that are actually correlated to the click, and then all these background health events. So one of the things that we first do is to try to figure out the noise that exists in general. And this, as Andy said, in all those spreadsheets, we need to do the same actions multiple times to start to understand which are consistent with the input action and which are just kind of events hanging around. And we basically like to slide those events out of the way so that we're not accidentally putting those background health events as a required event into the definition of the signal itself. The other kind of optional event is based on the context. I think we were really hungry the day that we came up with this idea, and basically we have the everything bagel and the plain bagel. And what I mean by this is we're going to create a user that has everything. Let's give every single thing we can think of to this identity and then compare the clicks. So in this example, this identity, it has multiple group memberships, it has a permissions boundary. We can see that group also grants it different attached policies. We give it tags. From a credentials perspective, it has a login profile so it can log in interactively. We have an MFA device, 2 active access keys, SSH keys, again, get credentials, key spaces, even some signing certificates. Now, the plain bagel has nothing. No permissions, not even a login profile, so even less than our no permissions users. So if we were to compare clicks looking at these different users, what differences would we see? Well, if we click into the plain bagel into the permissions tab of the IAM dashboard, we can see these events, and then the everything bagel has just a few more events. If we were to compare, also at the bottom we have a similar scenario where the access key is mentioned. To Andy's point, it's like in the last example. If keys are present, oftentimes that will generate additional events. But here's what's funny is that even the user agents are different in some of these. Those are 2 different versions of the AWS internal user agent talking about the same key. So there's a lot of interesting, I wouldn't call them discrepancies, but maybe some redundancies that we see, and this is very, very different across many different services at AWS, which makes sense. There are many different teams that work on these different services, and so even the kinds of background events that occur, or even kind of the style of how the front end and back end is programmed, becomes a little more evident as you spend a lot of time going through these different services and seeing how they're mapped. But if we're just to compare these events for the everything bagel and plain bagel user, we'll see in the green boxes are the common events that are there no matter what. And then in the yellow and purple, we have the optional events that are dependent on the context. If we click into the security credentials, we'll see a pretty similar story. Again, most of these events, all the ones in green are the common ones no matter what, and then purple are the different events. Again, in this case, based on if an access key is present for that user.
So we were talking about the differences between 2 IAM users, the everything bagel and the plain bagel. But if we're trying to look at the bigger picture, let's just take a step back and see what's actually the difference between doing some of the previous common events in CLI versus the console. And for that, we're going to look at from the AWS CLI perspective, the Boto 3 and the console. Let's see what steps we need to produce. We need to create a user named Kryleva, create an access key, and attach a user policy to this user. What events are generated in the CloudTrail? We have only 3 events that are generated, and with some differences between each other, speaking on user agent terms, because the event source and the event name are appended at the back of each user agent. So that's what makes them different. Going down to the Boto 3, where we are doing the same exact steps, create a user, create an access key, and attach a user policy to it. What events are generated? The same 3 events, with just one difference between the previous scenario, because the user agent is simpler now, because it's not different across these actions. Moving down to the last scenario, where we have the console, where things start to get intense. Now, we're not just going to show how much events will be occurring, but we also do a breakdown of each click that the user needs to make in order to recreate the same actions we did earlier. So buckle up and let's see what's going on. The first click is the console home click, or the home page that we get redirected once we log in into the console. So that's account for 13 events generated. Now let's put that to the side and keep track of the total number of events. Typing into the search bar, or searching for the IAM service, holds for 1 event, and immediately we get thrown at the IAM dashboard for a total of 8 events. So we have 9 events going on there. We have the IAM user click, or the user breadcrumb underneath the IAM service, and that holds 18 events generated. And we're going to talk shortly about this, worst case scenarios of clicking this breadcrumb. And this is a pretty good, decent scenario, since we had only 3 users, available users to list. So we have 80 events there. Now we are starting the creation of the user. So until now, we haven't even started the process, and we got 30 plus events. Create user button holds 4 events, immediately creating or attaching a user policy to this user, which has 15 events. After this is the final step of this user creation, which has 3 events, and immediately we get redirected to the permission tab of this newly created identity. So 13 events there, and surprisingly, we have only 1 event generated from the create access key action. The user agents that were present are shown as. We have only 10 events that are generated from our actual user browser, and the other user agents consist of health, AWS internal, and some different AWS Java CLI user agents. And if we were down to look closely on them, highlighted in green and yellow, we'll see some differences between their versions. So for all of you threat hunters over here who are trying to do some sort of statistical data or baselining on these fields, make sure to first do a good data normalization on them. For comparison, 3 input events, 3 output events for both AWS CLI and Boto3, so very clean, very simple, and 73 events generated by those 9 clicks that we did in the console. I mentioned the worst case scenario, so here we go. We thought it would be interesting to approach this with a mathematical formula. So for this particular click, we have the constant 1, which is referring to the anchor event, 5 times n, where 5 is the 5 grouping of events, and n is the number of available users, so we have 15 there. And again, the access keys, where a user may contain 0 up to 2 access keys, and in our case, we had only 2 events for this, so 18 in total. But let's increase the number of IAM users and start listing them. For 20 IAM users, we get a total of 141 events. Let's try now 50. We have 351 events. And now let's try the maximum number of IAM users in an account, which is 100, and we get 701 events generated by that simple click. We approach this with other services as well, and we have the S3 service over here, where if we have 100 buckets available and list them, we'll get 421 events generated. Back to you, Debo.
Thank you. So how do we make sense of all this noise? You know, we've gone through, we have tons of Excel spreadsheets, we've consumed lots of coffee, we've made tons of notes on all these different events, and we've broken it out into the anchor events, the required events, the optional events. But really, we're just trying to bring meaning to a messy situation and aggregate this knowledge so that we can take all these input pieces of information and say, these are when IAM users was clicked. Or this is when a user was created. Or here's when an access key was created. And by the way, we also want to be very particular about the events that we know are not associated with input action. And let's move those health events out of the way. So what's the solution? Mapping. The way that we approach this problem is kind of a 2-pass approach. The first pass is based on adding labels to individual event evaluation, and then we go back and evaluate all the neighboring labeled events, and that's where we have the concept of a signal being created. And when we say signal, we kind of mean like, think of it like an alert or like a mapping, a click has been mapped to this grouping of events. So first, how do we define the signal? Well, we focus first on that anchor event, optional event, and required event breakdown, just like we showed in the previous slide. We also have metadata about the event. You know, what's the breadcrumb trail? How do you get to this click in the AWS Management Console? What's the URL? What's the summary? And are there fields that should be dynamically updated based on the anchor event or any of the optional events that are present in that click? And then we have additional options down at the bottom for increasing or decreasing the look ahead and look behind when we're evaluating the signals for all the neighboring labeled events. So pass number 1 is adding labels. So every single event is evaluated individually, and then based on very specific criteria of user agent request parameters, which ones are empty, which ones are not, and to then say we're adding this label, or as we can see here, these labels are all being added in this very particular order to this one event. These labels will come back in the second pass to then say, let's now go back through all the events, and we're going to stop at every anchor event. Think of an anchor event like one of the required events. So for every event, we evaluate all the labels. If any of those labels said, hey, my definition says this is an anchor event for my scenario, now that has received the anchor event equals true flag. So we go the second pass every event, we stop at every anchor event, and then we take that anchor event, its labels, and we go label by label, and then we evaluate the signal logic. So each label will say, my logic says go backwards 3 seconds and forwards 10 seconds, and look at every single event that also contains the same label, pull all those things together, and then evaluate that against the signal. If all the criteria is met, then create a signal for this, and then mark all these events as accounted for. They have contributed to a signal, they cannot contribute to another signal, and that's how we group those together. There's a long list of additional things that we thought would be cool to do. Most of them are things we just had to do. There were so many weird situations that we had to account for. So as you saw in the signal definition, we can dynamically modify the URL, the summary. We basically want to provide as much easy to consume information to the users as possible. So you can literally see if they clicked on the Everything Bagel user, here's the exact URL that has that information. If they clicked on IAM Users and it was those 100 users, then we want to list those 100 users or list the access keys associated with them. All this extracted information we use to update the summary or the URL. We also have in a JSON object called additional data. So you can always programmatically access all the information that we gathered for these signals. And we actually do that too, because in the last bullet point, we have the ability to do lookbacks. So sometimes when we get to a certain signal, we might look back and say, actually, we need to modify that last signal based on what our current signal is. Other times, the current signal could happen in 4 or 5 different places in the management console. So we need to know what's the last signal that just happened within the last 10 seconds. If that was IAM users create user, then I need to basically pull information from that signal, like what's the username or what's the username that we're adding a key to or something like that. We also have the capability of merging existing signals. This is important for very long-running signals where we don't want to define a super long look-ahead, but we can basically merge adjacent signals that are identical and that have matching extracted data. And so yeah, there's a lot of weird tricks that we had to do. Still give us some headaches to this day, but it's pretty cool and was really a fun problem to try to solve. So enough talking, enough slides. Let's actually look at a demo. So we have 2 quick demo videos here. And so for the first one, we're basically just going to, if we can go and play that, we're basically just going to walk through how does this all start? Well, a user logged into the management console and starts to click on some things. We're going to go really, really fast to cover a couple of different examples. So if a user goes in, they've signed in to the console home, they click the IAM service, they've listed some user groups, they clicked on users to list them, and let's just choose a user, in this case, Zero Petula. We had clicked on the permissions tab, security credentials. In this case, let's enable a login profile. Attackers like to do this, so now this identity can go in and access the console. Maybe we want to create an access key for ourselves. Well, there's already 2. Perfect. Deactivate one, delete it, and now let's go and create a new access key for ourselves. And these are precisely some of the steps we see attackers do once they log into a console session. So now we have given ourselves a login profile, we have created an access key. Next, let's go to Secrets Manager. Let's start to enumerate some secrets and see what's available, what values might I be able to extract from this environment. Another thing that we see attackers do. In this case, there's only 5 secrets, so we'll click on this one, Opniri. We'll look at the overview page, and then we'll click on the retrieve secret value so that we can look at that secret. But you know what? This is kind of boring. Let's actually open up CloudTrail, just like real attackers do, and let's programmatically extract all these values into a file called secrets.json, and then conveniently, we can just click and download that file out of the console. All of these actions are recorded in very different ways, and pulling these all together was another great headache. But as you'll see in the next video in just a minute, it's pretty neat to see how all this can come together in a readable fashion. So there's our downloaded file. Next, let's go to the S3 service. Who doesn't like to look at some buckets? We're basically going to list some buckets, and then we're going to choose one in particular to click into. And so kind of keep in mind these different names that we're clicking into. So Zero Flia bucket, we clicked on the Objects tab, Permissions, Management, Access Points. And then lastly, let's go to EC2. This is one of my favorites. The EC2 dashboard is not super interesting from a volume perspective, but that second one there, EC2 Global View, this thing takes so long to run, there's literally a status bar. So you get really interested in how many events are actually being generated behind here. The answer is over 300 just for this one click. And we don't even have any EC2 instances in this environment. So it's pretty fun to watch. So in the next video, we'll see is let's actually do something with these event logs. You can actually query event logs directly in the API and pipe them into our tool, or in this case, we've actually downloaded this session and put it in the demo folder of the project. And so we're just going to pipe that in to add signal, which is adding the labels to the individual events. It's doing that second pass in generating signals based on the aggregation of that data. Let's just look at a couple of these and convert to JSON real quick so you can kind of see that we contain the original event, and then we also contain the enrichment object on top of it. In this case, this event wasn't part of a signal. So let's actually update our query to look for some examples where a signal was generated. So we'll call this a signal-bearing event. So this event is IAM list users, should look familiar. And then our signal here is really big. It is saying IAM users was clicked. And by the way, it was 33 users that were shown. Here are the users. 62 access keys at this time were present with those identities, and here they are. Here's the URL. And all that data we extracted is, again, in that additional data blob, so you can programmatically access it however you want. So we have some interesting context about this environment without needing any additional API calls, just from this offline log analysis. Next, we're going to do show event summary. This is going to show all these events color-coded to see which ones were actually part of a signal, and then we can see the signal on top of each one pointing down. And this gives us a little, slightly better view into what the signals were. Any extracted values are highlighted in green as well. But let's look at this one. This was that secrets manager where we clicked on the open URI user. So here, we can see it's these 4 events. Let's actually add a little more detail. And so let's say, show me details about each of those events. So now all 4 have a detail block underneath. So that first one is the anchor event. That was evaluated first, and then we can see it had 4 labels. The first 2 labels, the look ahead, look behinds, failed. The third one was successful. And we'll see all the other events were also successful for that label. That's why they were grouped together as part of this mapping. And then anything in purple, these are really helpful values for creating the labels, the request parameters, all that stuff. And so we wanted to make it easy to use whenever you're debugging or adding new data to see what are the precise request parameters and user agents I need to define if I want these events to be part of a new or existing signal. Lastly is a session summary. So just give me one line, how many events contributed to this line, and then what are events that did not contribute to a signal, so we can kind of see at a high level. Again, the extracted information is highlighted in a different color, and then at the bottom, we have some stats just on the number of labeled events, mapped events, as well as what services were involved in the mappings, and then for all the unmapped events, what were the services that were involved. 6 minutes, and that is our session.
So we were very motivated to do some front-end work stuff in order to give you a more friendly approach. So here we are with our UI visualizer. We have 3 additional buttons at the top right corner where you can click the mapped to get the mapped events, the unmapped events, etc. The table view is supported with dash AGGrid, so you have all these cool features of AGGrid like filtering based on different conditionals, rearranging the columns, also even sorting on different columns. We also gave a search filter where you can search as you type and get the view from all of the fields. Also, instantly getting the information on the placeholder above it in 2 different perspectives from the events and the total number of rows.
All right, so if we can go back to the slides, that's the tool. We've spent almost a year developing this with many, many hundreds of hours. And again, I think my eyes are still red from looking at all those Excel spreadsheets. So we're really excited to announce that this tool is now officially live. We'll have the link on the next slide, but let's wrap this up. What are the 3 takeaways here? Console sessions still matter. Attackers still use them, and probably more importantly for most organizations is normal users use them. But you still have to look at that activity and know, is this normal user activity actually normal? Is it something that we should be concerned about? And we seek to bring clarity into those situations through this tool. The second is understanding what your cloud logging options are. What are the limitations? What are the retention issues? Do you need more attention from a policy perspective? What tooling do you have available to look through these logs? And are you doing anything with it? Do you have the personnel or the capabilities to make sense of what's in the logs? Lastly is we've released this tool so that the community can use it and hopefully benefit from it, and even add your own signal mappings to it to basically help it be a more robust capability for the community. And with that, we just want to say thank you so much for your time. Thank you for your patience with the delay earlier. And this has been a lot of fun for us. Here's the URL to the tool. And here's our social media information. We'd love to, before we ask for questions, we'd love just to say, always feel free to reach out, whether it's in this room. If you see us walking around, we have some fun stickers to give out. But yeah, we definitely appreciate talking with the community, and so look forward to saying hello. And with that, thank you so much for your time. Any brave souls for some questions? Yes, I think there's microphones in the aisle there.
Perfect. Thank you, guys. Thanks for being here. I am a threat detection response cybersecurity analyst, so I am the ones that benefit from your kind of work. But one question I do have, we often have to disable some alerts / signals based on the amount of false positive alerts that we have. So based on your work here, what have you found that can decrease the number of false positives without increasing the risk of missing true positives?
Yeah, that's a great question. So nice to meet a fellow defender. So yeah, the question was like, how does our tool help reduce false positives? So what I would say is our tool seeks to bring clarity to a lot of events and give you an information on what that event was. I don't want to do any vendor bashing, but for example, if we were talking about guard duty alerts in AWS, this is precisely the kind of scenario that we see a lot of false positives with when a console session occurs, because there's all these crazy events that have never happened before. A lot of them are related to IAM, and a lot of those guard duty alerts will say anomalous IAM privilege escalation stuff. And the reality was you just click to view some users, like that's it. So our tool does not directly change any alerts. In fact, all the mappings are not, we don't view them as alerts. We view them as a simplified way to say instead of there's 1,000 events, there's 45 events. There's 45 clicks that occurred, and now you can kind of decide, is this normal or not? And so in some ways, the way that guard duty is, I'm assuming, baselining the activity, we kind of view, we view that in our team as how can we baseline these clicks? Instead of baselining individually hundreds of events, how often was IAM users clicked? How often was S3 buckets permissions clicked or objects or management? So this does not change noisy alerts from other tools, but hopefully even in the light of those noisy alerts, you have a little better readable way to look at that information to say, was there really something interesting going on in the session, or were they just clicking around looking at some users and buckets and stuff like that? I hope that at least partially answered your question, but thank you. Great question, by the way. Yes.
Hey guys, awesome work, by the way. So just wanted to ask, like, obviously cloud vendors, they don't come to you and say like, okay, we made a change to our logging, things have changed, so update your detection. So I haven't quite caught how you guys, like, is the signal creation process is quite manual at the moment. Have you guys considered maybe automating it? And if you have, what was some of the challenges you guys found?
Would you say it's pretty manual?
Yeah.
Yeah. The question, around is there any way that we can automate some of this? Because you are right, it is a very manual process today. I would say some of that manual process probably is like, quite personally, my level of OCD and wanting to understand truly all the differences, because we don't just want to group logs. We want to say what are the unique values from those logs we can pull out and say these are important context. But even some of the mappings we did a year ago and then retested some of them now, some of those had slight differences, like the EC2 service where it used to log a certain event as the AWS internal user agent, now logs your web browser user agent in some of those clicks. So I think there will always be those kinds of scenarios to manually catch up. Andy, I know one of the first things you did was actually, I think your first, one of your first approaches was to have like a browser plugin or something looking for the request, but I think kind of the Pong scenario was there's only so much you can see browser side. That ball gets bouncing around in the cloud and generating all those logs that are absent from that view. So we are certainly open for suggestions if there are more automated ways to do it, and would love to spare people some pain from all those blinding Excel spreadsheets for our tracking. But yeah, would love to hear your ideas if you have some around that, but great question. Perfect, sounds great, thank you. Any other questions? Awesome. Well, thank you again for your time, and we'll be around. If you see us, say hello. And thank you again. Have a great day.